Yes, thank you, Peter, for the kind introduction, and thank you for having me here to speak to everyone. So let me tell you a little bit about myself. So I started working at Arrival just over 4 years ago now, which is quite a long time for such a young business. And my background is in composite materials, so I've worked in composite materials my entire career. And I joined Arrival really for the chance to make a difference. So to actually get the chance to start on a brand new platform and apply all of the composite development work that I've done throughout my career and get it out there into the world. So today, what I'm going to tell you about is a little bit about Arrival itself, our vision, and our journey to create our electric vehicles. And specifically on a case study that we have for one material development project that we did to hopefully that will showcase Arrival's mission and our approach to sustainable materials. So Arrival started with a vision, right? So we wanted to create a brand new method, a radically different way of designing, producing and using vehicles. So when you look at the automotive industry today, it is extremely efficient, right? It does what it does really, really well, and it's based on a model that is decades old and fundamentally hasn't really changed. It's only done incremental improvements on the theme that it has. So it uses massive factories, like very, very large units in locations that are often far away from where the vehicles are used. And that means that they have complex logistical networks to ship parts and vehicles all across the world, back and forth. It's a system that requires billions of pounds of investment to get set up. And once you are set up, you're locked into producing upon hundreds of thousands of vehicles of the same type in order to make a profit, right? And once you've set up and you've tooled up, you make that one vehicle for a long, long time. So Arrival started from a blank sheet of paper, and we asked ourselves, right, what would we do if we didn't have any constraints? Like, what would be the best way to design, to produce and to use an electric vehicle? We looked at all the existing technologies of the day, and by starting from scratch with no prior assumptions and no legacy, we were able to like spread out, I guess, and really take advantage of new technologies that have come along and put them at the core of our vehicle design and production. So we were aimed to make vehicles that were affordable, have amazing user experiences, and to ensure that we contribute to the goal of getting cleaner air in our cities. So the radical new method that Arrival pioneered is embodied, I guess, in the MICROFACTORY. So the MICROFACTORY is the heart of the Arrival vision. It allows small footprint facilities to be set up really close to local demand. So imagine if you had a large city that required electric vehicles, a lot of them for delivery, we could set up really close to urban centres to provide that like supply close to the demand. We aim to use local resources wherever possible and also provide jobs to the local economy. Our microfactories also have a much lower investment to set up, and that means that they can be really flexible to meet local needs. So we're not tied in, as you are with a traditional factory, to set up for however many years and never change what you're doing or where you're doing it. So to give you a sense of size, a microfactory is approximately about 20,000 to 30,000 square feet. So it really does allow us to work in spaces that previously weren't really feasible to set up this kind of operation. So building locally is obviously integral to the vision, we're closer to the customers and to the cities, and this all allows for really greater customization in what we deliver. So one of the main enablers to get the MICROFACTORY vision into real life is how we approached our material development and material innovation. And Arrival's always seen our material innovation as a core part of the business as a whole, and one of our major steps to success, right? Which is a nice place to be, sitting in the materials team. So when we started out, we knew that existing technologies and existing materials on the market would not provide sort of the radical impact that we needed to make our vans a success. So when I started at Arrival, we were sort of at the beginning of the journey, and we were starting to look for solutions that would suit Arrival, like specifically our vision and our way of producing. So that started out our journey to develop the Arrival composite solution. So this composite solution was specifically developed to support our body systems. And when we started out, we knew that we needed a material that could be sourced around the world. So a lot of you, often as a materials development engineer, you come across loads of great materials that are really exciting, but can be limited in their supply to one niche supply in one part of the world. And that sort of limitation would be extremely difficult for a company that's planning on expanding worldwide. Obviously, we needed to produce really, really durable panels and lightweight panels, right? So we're aiming to be in competition with standard stamped, like for example, steel panels that you see on traditional vehicles and delivery vans, and they have been designed over decades to be extremely efficient, right? So our goal is to be lighter weight than those, and at the same time developing a material solution that will allow a process that is MICROFACTORY friendly, right? And it was really important to us at the time that our material and process was scalable through different volumes of production, right? Because if you design a part, it's so powerful to be able to prototype it really quickly. And oftentimes, if you choose a material and a process that only suits really high volumes, it can be really difficult to get that first look and feel for what your part's going to do. So that's a really big enabler for us to be able to make prototypes really quickly. So essentially, we developed our Arrival composite, right, to be durable, lighter, and all that good stuff, and be MICROFACTORY friendly, which is a key factor and not the easiest thing to do. So what does it take to be MICROFACTORY friendly? Obviously, you have the size limitation. That's the most obvious thing, to have a small footprint. But we're also aiming, and what our system delivers is radically lower tooling costs. So when you set up a factory, it should be easy, right? You shouldn't have to grin and bear massive tooling costs. So one of our fundamental principles is the low tooling cost that this offers. We developed a process from scratch to match our materials that we've developed, and it doesn't require heavy presses, so it's not classified as heavy industry, which also is a major enabler, right? So we can set up facilities where heavy industry might not necessarily be able to because of its proximity to residential areas. So that's an absolute must. One of the other driving factors for our MICROFACTORYs particularly was that the materials that we chose did not create a hazardous environment for the workers in the factory. As a composites engineer, that's not necessarily always easy to do because a lot of composite materials do have very hazardous elements within them. So our Arrival composite was developed with that in mind, right? And we're very pleased to say that it does, creates a non-toxic environment within the MICROFACTORYs. And in terms of the molding process, we've developed in-house, again, our own process to heat and mold for composites. And recently we've done all the background work on that to properly quantify the impact, and we've come up that it's a 50% reduction in total energy compared to conventional methods, which is really nice to hear. But obviously we started at the beginning with a concept that we knew, and it's often only when you get to the later stages that you get to really quantify that in numbers. So it's really satisfying to see the impact being proven. So obviously the material and the panels that we produced had to be competitive against what exists in the market, and by focusing on a thermoplastic matrix right from the get-go, we knew that it had the potential, right, to improve the durability of the panels. And we are super proud of how that turned out. So we like to show this video as a back-to-back test of what our panels look like. So we have a nice steel panel, and that's what happens to it when you hit it. And this is one of our panels, and it bounces back. So we're really proud of this outcome for our panels, and it means that essentially fleet owners, so the operators of our vehicle, have the major benefit of having increased uptime, because the worst thing for a fleet owner to have is the vehicle's out of service and in the shop for repairs. So this means there's much less wasted time going back for any dents and things like that a normal steel vehicle may have to go back in the shop for, because fleet operators obviously want their vehicles to look smart because they're champions of their brands, and this enables that to happen with much less cost, be much more resilient. Another major goal for us is that when we started, we envisioned a solution that would remove the need for paint shops, right? So paint shop adds costs, toxic materials, and also as well as the energy and water usage around that for a factory, right? And it just doesn't really fit with the microfactory vision. So when we started out, we were quite clear that we wanted to produce a durable surface straight from the mold, right? That can go straight out into service. What I didn't realize at the time was, again, once the numbers have all been calculated, is, oh, sorry. Oh, don't know what happened there. Sorry, is that actually 80% of a vehicle's water consumption from the production comes from the paint shop stage of the process. I didn't realize that. So what that means is, because we have managed to eliminate the paint shop entirely from our production process, the arrival solution should have less than a quarter of the water consumption of a industry average passenger vehicle. So we are really proud of that achievement. And what has allowed us to get there is that we control the chemistry in the entirety of the composite. We control each layer, and we've managed to create a system that works in harmony all the way through processing and during service. So it's that really careful consideration and balancing of each requirement and the control over each element that's allowed us to achieve that. And another great benefit is that the color of the material isn't just on the surface like a normal paint finish would be. It's integral to the entire panel. So that means that you get some more scratch, you get some more scuff. It's not a big deal like it would be on a steel or metallic panel, right? Because you don't see it as much. It doesn't obviously introduce rust hazards to the vehicle. And again, that's like a major benefit for fleet owners and operational efficiency. So it's got sustainable benefits, it's got benefits to the end user. So it's, yeah, a great part of our arrival composite solution. And really, like I said, we have control over every element that we have that goes into our composite. So we've worked really hard to understand and manage our supply chain all the way through, so at every level. And it's that level of control that means that we have the full scope to change any part of our material properties or features. So we can tweak as we need to suit different customers, different environments, anything that we need basically. And it's only through that level of control of the supply chain that we've managed to develop what we have, and that hopefully it will continue to reap benefits all through the future. And obviously it also allows us to source as ethically as possible from as local as possible sources, which is really important to us. And it allows us to have a much better understanding of the material, which gives us major benefits when we come to the end of life of our panels. So we were in a really strong position when we started out, because the end of life conundrum was something that we considered really early on in the process. So right at the beginning, it was a major requirement for us. And that made a big difference in, I guess, the success of the end of life options for us. Right? I've often worked in my previous jobs and projects where you have to sort of shoehorn in an end of life solution for a material that nobody really thought about that when we created it. So as it stands, we have proven several second life applications for our materials and the panels, and we have deliberately designed in applications for the second life materials into the vehicles themselves. So we have designed for circularity right from the beginning of the project. Also, our recycler even has value on the open market as well, right? So we haven't just created a secondary material that's useful to us and nobody else, because that would limit our options. So it's really good to know that there's many available outlets for this new material. But of course, it's not really easy to implement solutions like this at scale. We've hit many challenges when it comes to finding the right partners and the right supply chain to help us with this. Oftentimes I think the supply chain maybe in this area is not quite ready or able to support us with this. So our future challenge really is to make sure that the end-of-life options for materials are widespread throughout the industry. So Arrival is a member of the Platform for Electromobility. That it brings together 40 or more different organizations from industry, civil society, cities, and covers all transport modes. So this platform we all have the same aim within it, and that's to speed up the electrification of transport in Europe. So we've recently shared a paper with the EU Commission, who are looking at the Sustainable Products Initiative. And in that paper, we call on policymakers to encourage more sustainable behaviours in manufacturing by linking incentives to the sustainability of materials. So to get there, we need supportive frameworks that incentivise future improvements in recovery, recycling and reuse of components and secondary raw materials to promote circular value chains. So specifically, we believe there should be more focus on the sustainability beyond CO2. For example, reduction and prevention of impact of water use and biodiversity and other things like that. So we would go beyond tailpipe emissions and consider life cycle analysis. So this is the key to truly track end-to-end sustainability of your entire product. So we encourage circularity, recyclability, and energy efficiency of vehicles, and that these incentives should be pivoted to those products and materials that deliver best on those criteria. So obviously we support the advancement of sustainable and circular products throughout the value chain, and that includes investment into the electric vehicle management, focusing on harvesting parts for circulation, advanced disassembly, and for sorting, separation and recycling, because it's really crucial that these big topics are things that we need to tackle as an industry as a whole, because as we've been learning, it's extremely difficult for individual companies to do it on their own. So we look forward to the support and coming together of the industry to really tackle these issues. So obviously, Arrival's end goal is clean, circular and equitable. So this is our major goals, and this is what we work towards. And I hope that this little case study displays that really well. that is the end of my presentation.